This is the notes video for H1-6, Solving Linear Systems of Equations Review. So the first question asked, what are three methods of solving linear systems of equations? Oops, there's a typo, but we'll live. So, in the past, hopefully you have learned several methods. One of them, if we think about it, is the most visual method, right? If you've got two lines and you're looking to figure out where they cross, right? That would be the graphing method. Okay. There's one where we isolate a variable and we try to plug it in for something else, or the expression. So we would refer to that one as substitution. And the third method you should have seen in the past is the elimination method. Now, if any of you haven't heard of substitution, some teachers and schools call this the equal values method. So if that's what you call it, that's okay. That means the same thing. All right, and then it says the three types of solutions for a linear system of equations are, well, one would be a point, right, which is like an ordered pair, like our x comma y. So we refer to that as an ordered pair. They could also have infinitely many solutions, or an infinite number of points. And that is when we have coinciding lines. Okay, and then the other option there would be no solutions. And that's when we have parallel lines. So real quick here, we can kind of review those, right? So an example of when we have just a point here, if we look up at that graph I just drew up above there, right, where we have two lines that cross right there, that ordered pair, x comma y, would be the solution. If we had two lines that just never intersected, that was the option here, actually number 3, no solutions, because the lines are parallel to each other. And then if you have a line here and they actually are like almost like right on top of each other, right? That's what we call coinciding lines, and they would share infinitely many points because both lines are made up of an infinite number of points. So they would share all of their points together. Let's go ahead here and look at some of our algebraic methods. So we're not going to focus on the graphing part right now. We're going to focus on the algebraic methods. First example is going to ask to solve the system using the substitution method. So remember, substitution here, this is the one where we want to isolate a variable. Okay, so as we look at our two equations, we have 3x minus 2y plus 2 equals 0 and x plus 3y equals 14. As we're kind of examining these, when we look at this x, this is probably going to be the easiest one to isolate and get by itself. We can take our 3y and subtract it from each side so that we now have an expression that x equals, right? So this is going to zero out. We've got x is equal to 14 minus 3y. And since x is going to equal 14 minus 3y, wherever we see the x, we can put that in its place in the other equation. So we're going to take out this x up here, and we're going to end up replacing this x with this expression. So now we've got 3, and then we're going to say times the quantity of 14 minus 3y, right, because that's what x equals, minus 2y plus 2 is equal to 0. Let's go ahead and distribute our 3 through. We've got 14 times 3 should be 42, minus 9y, minus 2y plus 2 is equal to 0. Let's go ahead and combine our like terms. We've got negative 9y and negative 2y. And then we've got 42 and positive 2. So that should give us negative 11y plus 44 is equal to 0. And then let's just finish solving. I'm going to subtract my 44 from each side. We now have a negative 11y is equal to negative 44. And it appears now that y is equal to 4. Now we're not finished though, right? Because now that we figured out that y equals 4, we need to figure out what x would be so we know the ordered pair, the point where they cross. So remember substitution, we're going to choose either equation and we're going to substitute that 4 back in for the y value. So I'll use the top one here. Let's see, 3x minus 2. Instead of times y, we're going to substitute the 4 in, right? So this is like our y value. And then we have plus 2 is equal to 0. So this would be 3x minus 8 plus 2. Should be 3x minus 6 equals 0. Add our 6, we've got 3x equals 6, so x has to equal 2. Which now looks like our point where these two lines cross would be the point 2, 4. And we can check it by plugging it into the other equation that we didn't use. We can take this one and we can say, all right, if this is x and this is y, it should be true when I plug that in. So 2 plus 3 times our 4. Oops, I forgot my 3. And then that should equal 14. Well, 3 times 4 is 12. 12 plus 2 is 14. So it checks out and we know that we have the correct answer. So this is just a quick review of the substitution method. Remember, we isolate a variable to start out and then substitute its expression into the other equation. Let's do a second one. So if you want to try it on your own, you can pause the video, give it a shot, and then replay it to see what the answer would be. I'm going to go ahead here and get started. I see here that I already have this y isolated by itself, and it equals negative 1/2 x plus 4. So since this y is already isolated, I'm going to take that expression that it equals, and I'm going to put it in for the y in the other equation. So x equals 2, and then we're going to put the quantity of negative 1/2 x plus 4, and that should equal 1. Let's distribute through. We have x, and then 2 times negative 1/2 would be a negative 1, so we have x minus an x plus 8 is equal to 1. These two x's are going to cancel each other out, leaving us with 8 is equal to 1, which is a false statement. So remember, when we have a false statement, 8 does not equal 1, okay, that means that we're unable to solve to get a value for x, which means in this case here, when we have no solutions, we have parallel lines. So we'll say no solutions because parallel lines. And if you want, right, we already know what this one is in slope-intercept form. We could take this equation to just double check it, put it into slope-intercept form, just to make sure that it has the same slope and a different y-intercept. Right, we'd subtract x from each side. 2y is equal to negative x plus 1. We divide by 2. We get y is equal to negative 1/2 x plus 1/2. So there you'll see the same slope, but different y-intercepts. So no solutions, they are parallel lines. Next example, solve the system using the elimination method. Elimination is one of my favorite methods. I think a lot of people like it because I think it's just a little bit more efficient. So as we look at our first one here, we have 6x plus 5y equals -2 and 2x plus 3y equals 6. These ones are both in standard form. So remember, standard form is when we have ax plus by is equal to c. Okay. So our objective when we use elimination is we want to add the two equations together, but we want to eliminate a variable by adding, essentially it's what we call a zero pair, right? So that they cancel each other out. So in this case right now, if I tried to add 6x plus 5y equals -2 and 2x plus 3y equals 6, nothing would cancel out. We'd have 8x's, 8y's, and 4 for our constants. So we're going to alter one of our equations so that we can have opposite terms. So I'm going to take this second equation and I'm going to multiply it by a -3. And hopefully you'll see why I'm doing this here in just a second. We have 6x plus 5y equals -2 still. Now when I distribute this -3, I have a -6x. I have minus 9y. And then -3 times 6 over here equals -18. Now when we look to combine the two equations, right, we add them together, these are opposites, so our x's are going to cancel. 5y and -9y gives us -4y equals -20. And when we divide each side by -4, we'll get y is equal to 5. Okay, so that's half of our answer. Let's go ahead here and plug that 5 back in to figure out what x would have to be. So I'm going to plug it into the top one, 6x plus 5 times 5, right? We're substituting it in for the y, equals -2. So 6x plus 25 is equal to -2. Subtract 25 from each side. We get 6x is equal to -27. Divide each side by 6. X equals, I think that's -4.5. So you see there, x is -4.5 and y is 5. So our solution looks like it's -4.5 comma 5. And we'll check this by plugging these points, the x and the y, into the second equation to make sure it makes it true. Right, so this is our check. We're going to say 2 times -4.5 plus 3 times 5 is equal to 6. This is going to be a -9 plus 15 is equal to 6. And 6 equals 6, so we know we're correct. So the final answer is right here, right? We write it as an ordered pair because it's a point. Number 4, solve the system using the elimination method. Okay, with this one, we have x plus y equals 4 times the quantity of y plus 2, and x minus y equals 2 times the quantity of y plus 4. Now, before we start trying to use the elimination method to put everything together, let's simplify it here and get our like terms together if possible. Right, so I'm going to take this and I'm going to get rid of these grouping symbols by by multiplying the 4 through. So I have x plus y is equal to 4y plus 8. And then I'm going to subtract my 4y just to get my y's all together. Move that over, keep my y's lined up. So I have x minus 3y is equal to 8. And then we'll do the same thing on the second one. So we have x minus y is equal to, we distribute, we have 2y plus 8. And again, I'm going to combine my like terms. We have x minus 3y is equal to 8. And what you hopefully are noticing here is suddenly We have x minus 3y equals 8 and x minus 3y equals 8. So this really means that these two equations are actually the same lines. In which case, once we notice that, like if you wanted to do the elimination method still, right, we could take this here, we could multiply this one all by like a -1 and rewrite it under here. So -1 times x would be a negative x. -1 times -3y would be plus 3y. And -1 times 8 would be a -8. If you can do this and add them together and you basically get everything cancels out and you're left with 0 equals 0, then we're going to say this is infinitely many solutions. Okay, this is infinitely many solutions because we have coinciding lines. All right, last one we got here is example 5. Again, they want us to solve this system using elimination. So when we look at this one here, the way it's set up, right, if we took everything here and we tried to add it the way it is, would anything cancel out? Would the p's or the q's cancel out? And in this case, no. So we are going to need to actually alter one of these equations, or both. You could do either way, just so that when we add them together, something cancels out. So I'll tell you what I'm going to do. I see since the q's are already opposite signs, I'm going to multiply this one by a 5, and I'm going to multiply the top equation by a 3. Let's see what we get. So, oops, make sure I don't make a boo-boo there. This is supposed to be a 5. There we go. So 3 times 3p is 9p. 3 times 5q is 15q. And 3 times 15 is 45. We do the second one. 5 times 2p is 10p. 5 times -3 is -15q. And then 5 times the -9 would be -45. Let's add them together. So our q's will cancel. We have 19p is equal to 0. And we'll divide each side by 19. We get p is equal to 0. Now don't freak out, right? Because 0 is a number. So let's take that 0 and plug it in to see what we get for q. 3 times our p, which is 0, plus 5q is equal to 15. Well, this is just going to be 0. And then we're going to solve for q by dividing each side by 5. We get q is equal to 3. So the solution looks like it's going to be, right? And we always write these in alphabetical order. Okay, so PQ. So this would be 0, 3. So if you have questions on this, please make sure you reach out. If you're wanting to check your answer, then remember we'll take that 0, 3 and you can plug it into the other equation that we didn't really use. Like we used the first equation up here, so we'll use the second equation to check it. We'll use the 2p minus 3q equals -9. So it would be 2 times 0 minus 3 times 3 is equal to -9. And 0 minus 9 is -9, so we know that it is correct. If you have additional questions, please make sure you mark them down. See me in class. Go to Math Help. Okay, whatever helpful resource you can find.